Hello, welcome back. Now we're on 6.4. This is the last part of this chapter, and as I always say, I don't have any credentials. I'm just a student. I'm your study buddy. Let's go. Let's get into it. 6.4 is measures of dispersion. So, in the last chapter, we did the averages, the mean, median, and mode. But in this chapter, it's about how spread your data is. So the first thing you have to know is the range of your data. The range of your data is the maximum value minus the minimum value. Quartiles are values that divide the data into quarters. Quartiles sounds like quarters. That will be easy to remember. There's a lower quartile, which is written as Q1, and an upper quartile, which is written as Q3. So, at the lower quartile, you have 25% of the data below it. And at the upper quartile, you have 75% of the data below it, but you also have 25% of the data above it. And in the middle is the median, which we talked about in 6.3. And there is an interquartile range, and the interquartile range is the Q3, so the upper quartile minus Q1, which is the lower quartile. And this just shows the data spread to see what is the difference and to see any extreme values. How you would find these quartiles is, again, putting numbers in a list from lowest to highest. The middle is the median, and then you basically find the median again, but with all the numbers below the actual median, and the middle of that is the lower quartile, and you do the same thing with the above, and that is the upper quartile. So you use these quartiles in making a box and whisker plot. So to make a box and whisker plot, you need 5 different values. You need the minimum value, the first quartile, the lower quartile, the median, and the third quartile, the upper quartile, and the maximum. So when drawing it, I made a mistake and I accidentally wrote that the scale was called the whisker, and no, that is just not correct. That is not the whisker. The whisker is the line that I will point out soon. Not this. That is not the whisker. That is just the scale, but ignore that. So if we say that the lower quartile is 3, the median is 5, and the upper quartile is 7, then the Boxwhisker plot would look like this. You draw lines at the 3, 5, and 7, turn it into a box, and then add lines to the minimum and the maximum value. And that is it. That's all you need for a box and whisker plot. And this shows how spread your data is, because you can see that there's a lot of values above the 25th percent, and from Q1 to Q3, that is 50% of your values. So you can sort of check how long the box is and how wide the box is to see what percent of people got what. Extreme values are called outliers. Outliers are 1.5 times the interquartile range, and then take that value and add it to the upper or lower quartile, and if you have any values that are higher than that or lower than that number, they are outliers. And these may or may not be removed from your data. Let's take 7 and 3 as an example. So 3 is the lower quartile, 7 is the upper quartile. So you get the interquartile range, which is 4, and then times it by 1.5, which is 6. And then you take the upper quartile plus 6, which equals 13, or you take the lower quartile minus 6, which is -3. Sorry, it got cut off the page again. This means that if you have any values in your set of data that is above 13 or above, or -3 or lower, they are extreme values and outliers. So there are different reasons for either removing an outlier or keeping an outlier. So if you were to remove an outlier, it would be due to the result not making any sense. So it's not possible, and this is usually due to something was measured wrong, or someone lied, or something like that. For example, they said that they have 2.2 cats. It's not possible. If I saw that in my data about pets, I would remove it. And in the book, they use the example of someone writing that they're 382 centimeters tall, which is not really possible. I mean, there might be someone that tall. Don't check me on that, but for the general population, that is just not possible. And to keep it would be, if it makes sense, you should keep it, because otherwise you are messing with your data. You are making biased data. It's not representing what you actually got. So here is just a quick part about percentiles. So essentially, this is if you want to compare your score to everybody else's. Let's say you're doing a test and you get a certain value, but how do you know that you did well unless you compare it to other scores? Now you can do this by using the quartiles. So if you have the lower quartile, it's the 25th percentile. This means you scored better than 25% of people. If you use the upper quartile, it's the 75th percentile, which means you scored better than 75% of the people. So maybe the most important part of this chapter is about the standard deviation. So standard deviation is essentially a way to measure how spread out or dispersed your data is. It is very, 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 very sensitive to outliers. If there's a single outlier, it could change the entire graph or number. Now there's also this thing called variance, which is essentially what's inside the square root. If you just remove the square root of standard deviation, that would be the variance. And the variance, the reason why we add that square root is actually to make it in the same units as the actual data set, because the variance is not in the same unit as the actual data sets. Now, I am writing the actual formula right here, but you really don't need to know it. Yeah, I know that might sound stupid, but just use your calculator. They'll never ask you for standard deviation without a calculator. At least that's what my teacher has told me, so hopefully she's not lying. And I would show you how to do it on the calculator, but we all probably have different calculators, and I have a very old calculator, or our school gave us decently old calculators. So I don't think it would be very helpful for me to show you. So I think you should Google the model of your calculator and how to find standard deviation on that calculator, because usually there's a button or something. It's not like you have to type in the whole thing. And if you're wondering what these symbols stand for, the symbol below the N is sigma, which is the sum of. The X with a line above it is actually the mean. But yeah, only use your calculator. Don't be bothered with doing all of that where the data is. And these are like the 32% above, 32% below. And you can see how dispersed or spread the data is. And low standard deviation shows that data points tend to be closer. So if it's a really high standard deviation, that's usually not the best thing. And the sign for standard deviation is actually the lowercase letter of the sigma. And for variance, it's just the lowercase letter of the sigma squared, because that is literally what it is. It's just standard deviation squared. And now we are done with all the information for 6.4, and it's time to do the quiz. Here is your set of data. And the questions are, draw a box and whisker plot. I forgot the and, but that's okay. Find the standard deviation and variance. And what would happen to the standard deviation if you add 5 to each of the data values? Now, we haven't discussed this, but try and think about it and see what happens. And I also decided to explain what happens if you multiply everything by 2 as well. But don't think about that right now. I'll just explain that during the other thing. So, now you can pause and do this and come back when you're done. The answer for question 1 looks like this. So I drew out my scale and I decided to do it every 2 numbers. And for some reason I did odd numbers instead of even, which looks really bad, but never mind. Then I found the mean, found the lower quartile, and found the upper quartile. I wrote them down. The lower quartile was 4 and the upper quartile was 9. The median was 6. And that was it for that one. For question 2, I found that the standard deviation is 4.63, and for question 3, it's also 4.63, because if you add 5 to everything, the data is still the same amount of spread, because everything has added 5. It's not like you just added 5 to one thing. And the variance is 21.44 for both of them. But if you times it instead, think about it, then everything gets times instead. So then the standard deviation would be, let's say if you times 2, the standard deviation would be times 2, and the median would also be times 2. The reason why I'm mentioning this is because there are some questions in the book about it. And that was it for the quiz. And now all of chapter 6 has been completed. Yes, that was it. It's a very short chapter, but good job. Woo! Just put a huge check mark on it. And now that that is done, I will continue to the next chapter. I'll probably do chapter 7 next, and then I'll go back and do the earlier chapters later on. So feel free to subscribe, like, comment, and follow me at Johanna Frennert. And goodbye! Thank you for watching. Hopefully you learned something. Goodbye.